Okay, so as I said, alhamdulillah, we are already in week 8 now, and we have gone through some of the basic concepts of the object-oriented design in the first few weeks of the semester. Then we focused in the last maybe 2 weeks on architecture. So today, inshallah, we're going to be the last lecture on architecture. Just a small example which I brought in to complete the discussion. We talked about, if you recall, definition of architectures in the beginning, and then we looked at different styles, and we had a look at different applications of these styles as well, from Napster to Gontaila to Skype to Google file systems the other day. Again, the idea behind showing all of these different practical aspects of the systems are to make sure that we understand that sometimes we can just use these styles on their own, and sometimes we'll have to combine them, and sometimes we'll have to think out of the box as well to come up with the solutions. So today, I'm just going to give you, as I promised, a simple example, a very simple example on MapReduce, which is basically used developed by Google originally, and then of course, as I said the other day, Hadoop Google file system evolved into Hadoop. So basically, this MapReducer, how it really works on Hadoop. Now again, we have to take it with a pinch of salt here. Of course, we're not gonna be an expert of MapReduce in 5 minutes. It's more complicated than the way I'm gonna present it here. But the whole idea is that at least you are familiar with the terminology at least, and you can see that where it really is being used. Of course, I encourage all of you guys to have a look at this on your own time, and try to see what's happening there, and it's always a good learning exercise. But as I promised, let's look at this as an example, try to basically understand what happens there. Now remember what was happening in a Google file system. You had what? Clusters, right? Of normal commodity computers, right? Or normal hardware computers, and then you had basically the chunk servers, and then you have the mappers, and it had the metadata of the whole chunk files, right? Correct? Everybody was comfortable with that?
Yes.
Okay. So MapReduce, what exactly is a MapReduce? It's a data parallel programming model for clusters of commodity machines or normal machines. And as we discussed, Google file system, eventually Hadoop, basically is developed on a normal hardware. It doesn't really, uses any of the fancy big servers as such. And this MapReduce is developed as a programming model on such clusters of computers, data parallel programming. Of course, originally pioneered by Google, and it can process up to 20 petabytes of data per day, and even more. So it's just, we're talking about huge amount of unstructured data here, or semi-structured data. Of course, it's hugely popular. As I said the other day, this Hadoop project, basically you name an application which is using a big data and it's not using it, I'll be surprised. Yahoo, Facebook, Amazon, list goes on. What is Reduce used for? What exactly are these organizations using it for? For example, Google. Google uses it to build indexes of the search, or articles clustering for Google News, and list goes on. For example, Yahoo again uses it for building of the Yahoo search, or spam detection in their Yahoo mail. Or if you look at Facebook uses it for data mining. They use it for ad optimization. They use it for spam detection. They use it for fake news detection. The list goes on and on and on. So this is actually something real out there in the market, and this is something which is heavily used by pretty much any large organization, any large, such kind of applications. So what exactly it is? It's a programming model designed for doing efficient distributed computing. That's the whole idea behind this. It works more like a Unix pipeline. Remember the pipes and filter style, right? The basic pipe and filter style, right? The idea is pretty much the same, that you have an input, then you have a map and shuffles and sorts, and then you have reduce, and then you generate an output. So see, that simple architecture style, the pipes and filters, how it can, how these software architects have used the same concept and kind of, took it to the next level to solve a different kind of a problem. So far, so good. Any questions on this?
All clear.
Perfect. So, of course, it is efficient. And again, as I said, we're not gonna be an expert of map reduce in 5 minutes, but we'll just take some of these concepts or these things on the face value. Like they're very efficient for streaming through the data, pipelining of it, efficiently processing them on a distributed computing environment where the files are stored in different servers in terms of different smaller bits, because again the reason is the files are so big that it's now an unstructured or semi-structured. So the main features are that, of course, as a result of this map reduce, it helps the whole infrastructure have a load balancing. It's faster recovery from failed tasks. It has an automatic re-execution on failure functionality that, if in a large cluster, some nodes are always slow or flanky, so they can re-execute them. They can re-execute on the failed tasks as well because they are slow. So sometimes because they are slow, they may not be able to complete the task. So it has an inbuilt functionality of re-executing those failed tasks, and it has an application or inbuilt mechanism of optimizing as well with large data, bandwidth problems, all of that stuff. Because again, we're talking about not even terabytes and terabytes of data here. So of course the issues of the data, the bandwidth, all of this will come up, and this map reduce has all of that functionality inbuilt in it to basically kind of optimize this access, this processing of this huge amount of data. Of course, as I said, again, we have to take them on a face value. We're not going to discuss technically how it really does or why it works, but it's just one of these advantages it has. So as I promised on Thursday, I said that I'll bring some very simple one example. So I'm just bringing a very basic simple example for us to understand and see how really it works. So we're just gonna use a very simple example called word count example, and we're gonna just count a word from a file which has a bunch of words in it. So basically we're gonna do what is we're gonna do something called mapper phase, and then we're gonna have something called shuffle phase, and then eventually we'll have something called reducer phase. So based on an input, we will do a bit of a mapping, then we'll do a bit of a shuffling and reducing, and eventually you will have the final result. Let's look at this simple example. Let's see what's happening here. So this is your simple small file, right? For example, an input file, it has a text in it, and it has a different words in it, and you want to count these words. So on a map reduce functionality, a map reduce programming model, what really will happen is that it will split this into different units, then it will do mapping of them, then it will be doing the shuffling of them, and then it will be doing the reducing of them, and eventually you will have the final results. And of course, the problem is to count words in a given file. So basically, the mapper function or phase will do what? It will split the strings into individual tokens. So it will basically do what? These splitting will take place, and then you will be able to have individual tokens of them. And you will see, for example, the deep is being counted number one time here, beer is one, river is one, car is one, another car token is there, river is there, then you have another deer, car, beer. So it's basically doing this splitting of it, or basically what we call the mapping functionality. Then you have the shuffling one. Basically, it does what? In the shuffling phase, which is somewhere here, it will go on and execute automatically where the key value pairs generated in the mapping phases are taken as an input and then sorted as an alphabetic order. So remember, it has the same pipe filter kind of a mechanism. So output of this mapper functionality or phase is used as an input for the shutter phase or shuffling phase. And the shuffling phase, basically automatically what you're doing is you are, taking them out and sorting them in alphabetic order. So like in this case, it went through the whole of these uh, mapping outputs and said, okay, beer, okay, and alphabetically ordered, say beer, it happens 2 times. It will just show them to group them together, shuffle them together. Cars, it will shuffle them together. Deers and rivers, shuffle them together. And eventually you will have something called the reducing phase. In the reducing phase, all the keywords that are grouped together, these ones, and their values are added up. So basically it will just do a counting of them and say, beer has been, there are 2 beers, 2 times the word beer has appeared and car has appeared 3 times. And for example, river has appeared 2 times and eventually it will generate an output. So it basically map reduce takes an input, does this mapping phase where basically it's doing the tokenization of it, then it's doing the shuffling of it, then it's doing the reducing phase and eventually generating the output. One input of a one phase as an output of that phase is used as an input for the other phase, output of that phase is used as an input for the other phase, and eventually you get the output. Now, of course, one can argue with me here and say, well, I can do the same thing in using my ICS 102 knowledge, right? I just read the file, right? What's so special about it? The special thing about it is that, these files are not these 3-4 liner files. We're talking about terabyte and terabytes of data, right? And, it's terabyte and terabytes of data is you need more sophisticated functions to be able to go. You cannot just simply use arrays and those kind of, simple structures. Or those structures in a simple format, you cannot just use them to basically do a task like even such a task like counting the number of words in a file. Of course, you can do more sophisticated thing here. Any questions on this, please, before I move on? So far, so good, right? Do you appreciate the strength of uh, this modeling platform? Remember, it's on a distributed one. It's on a different distributed clusters. These files are not stored in one location. It's not like our ICS 102 files, which are on our laptop in one location.
Yeah, it's actually interesting to know about it.
Yes, it's and as I said a few slides ago, it's something which is practical. It's not something which is just research, or it's not just something which is academic. No. When companies like Google, Yahoo, Facebook, Twitter, if they are using it, and their whole infrastructure is developed on this and they use this to actually achieve their tasks, it means it's something worth investigating. So in a nutshell, we need to just understand this. I think I kind of used the ICS 102 example deliberately to highlight this point. An important point to understand or note is what? That this mapper class in the word count problem we just looked will execute completely on the entire file, not just in a single sentence. So it's not like, it will be doing this tokenization on a single sentence. No, go through the whole file, and this splitting and mapping is done on the whole entire file, right? And so for example, if you have 15 lines, then the mapper class will split the words of all the 15 lines and will form individual values of pairs of the entire data set. So it's again not like typically we use our typical file processing. And of course, the reducer execution will only begin after the mapper phase has been executed successfully, because it is more like a pipeline. It's more like a pipe filter style. I'm just using this as an example because we know pipes and filters start that the input or an output of the mapper phase will be used as an input for the reducer phase. So far so good, right? So everybody's comfortable with this? Any questions on this, guys?
Clear.
Clear, alhamdulillah, alhamdulillah. So basically, alhamdulillah, we are basically done with the architectural concepts, which I thought we as a 316 students should know. So, you know, with this, I think it's for time for us to move to the next phase of our 316. Let me stop sharing of this one and I'll share the other ones now. My mic was muted. Are you able to see the screen?
Yes.
Yes. Yes.
Okay, cool. Alhamdulillah. Now, what we're gonna do now is that since I said we're done with the architecture, we can always go on and we can talk about cloud and others and SOAs and so on and so forth. But that's beyond 316 because we need to cover some other interesting and important design concepts as well. So because 316 is quite heavy in a sense. It has a lot of different concepts which needs to be covered. So now we're gonna shift our focus to packages. Okay. And we're gonna try and understand that what is how we can design our packages. And for that to happen, we're gonna look at that if you have to come up and design with a package, you need to usually focus on two principles. The principle number one is the cohesiveness principle. All right, so we're going to look at this, that how packages can be designed from a cohesive perspective. And of course, we have multiple options or principles we can apply to come up with cohesive models. Something called common closure principle, or something called common reuse principle, or reuse release equivalence principle. So we're going to look at these ones today, and we're going to say that how these can be used to come up with packages which are more cohesive in nature. And eventually, we'll also look at the concept of package coupling. And then, of course, within package coupling, we also have multiple options or rules which we can follow. Something like acyclic dependency principle, stable dependency principle, and stable abstraction principles. Probably we'll look at these ones, inshallah, on Tuesday. Yeah, but we'll try to focus on these ones today. If we have time, of course, we can always continue, but our focus probably will be on this. Now, before this, what is the meaning of a coupling and cohesion? What we really mean by cohesiveness? Let's start with cohesiveness first. Any ideas?
Relevance, I think.
Yeah, the relevance is a good one, something which is related to each other. So what that really will mean from a package cohesive perspective, what will be that from a technically, from a design perspective, from a classes perspective, what that will really mean? What comes to your mind when we say cohesive package? We want cohesive package. We want packages in to be more cohesive. What that really means?
I think independent, maybe.
Maybe like when you join multiple packages, they mean something. They complete each other.
Okay. Any other thoughts? Any other ideas?
maybe multiple packages with fixed understood relationships.
Fair enough. Fair enough. Anybody else would like to make a comment before I discuss about them? Probably not. Okay. So before I dig into these principles, let's first of all understand them. What's a package first of all? When I say I have a package, I want to design a package. What did that really means?
Collection of things, but here, when you are talking about programming, we mean classes.
Exactly. So we are trying to basically in our system, we will have, this is our class diagram, you know, we will have multiple classes in it, right? And we already know some of those principles: abstraction, encapsulation, inheritance, and so on and so forth. So we'll have so many classes. Now these classes needs to be grouped together somehow. And the reason they need to be grouped together is that we want to group them together for multiple reasons, right? For deployment onto the architectural components, for organizing them in a better way, so on and so forth. So when we say package, it means, by the way, UML usually use this is a symbol for package. So packages means this whole classes I have in my system, I want to, for example, put these ones in this package, and then I will have another package here. You guys are seeing what I'm drawing, right?
Yes.
Yes.
Yeah. Okay. So and we
Yes.
want to, yeah. So we want to put these, three classes in package A, for example, and we want to put these three classes in package B, for example. Okay. Now the meaning of the cohesiveness is what? Cohesiveness means, as we said, the related classes. So basically, we want to come up with packages in such a way that they are cohesive. So all the classes, these three classes, I'm putting them in package A, or these three classes in package B, they should be cohesive somehow. They should be related to each other somehow. It should not be random, right? This is a principle we will try to achieve when we draw package diagrams, that we want them to be together in using some logic, some reasoning. And similarly, the coupling means that, of course, these packages are not in isolation, because these classes are not in isolation. They have association relationships with each other. They have, inheritance relationship with each other. They have dependencies and so on and so forth. So hence those relationships will still be there. Because, for example, if this class has an association with this class, and if you're going to put them together, put them in two different separate components, packages, then of course there will be some dependency between them, right? Is this point clear? Why do we have dependency between them? Why we have this coupling happening? Relationship is there, right?
Yeah.
Right? Because let me repeat it one more time. Because we're gonna try and put these packages into different classes into different packages, and of course we're gonna try to make them cohesive, which means they are related. This means these classes will go into different packages, and of course we know from our class diagram or from program that they also they may have associations, they may have some kind of a relationship between them. Hence, the classes, even when you group them together in different packages, as a result, they will have some kind of relationship between them. And of course, we always try to do what? We try to increase cohesive. So we are always interested in having packages which are more cohesive in nature. And we are always interested in reducing dependencies. Why is that?
So we can it helps reusability.
Yeah,
Overall,
it helps. Yeah, it helps reusability, definitely. It makes the whole system what? Modular, right?
yeah, exactly.
Exactly. And then, of course, that is easy for maintenance and testing and many other things and changes and so on and so forth, correct?
Yes.
Okay, alhamdulillah. Everybody is on board with me so far?
I have a question.
Yes, go ahead, please.
Can it be that the package inside another package?
Okay, so package within a package, right?
Yeah.
I think packages within a package actually, it kind of moves. Okay, let me answer it this way. I think from a conceptual perspective, nobody will stop it, but more practically, it will be the case that, remember these packages, the reason we are grouping these classes in different packages is because at the end of the day, these packages will be deployed on an architecture, right? So if you have, for example, a mobile application and you are using a client server architecture, right? So probably this is your client and this is your server. Then you need to think about, where these classes will be deployed, where these packages will be deployed, right? And there it is possible that on a server, for example, you have multiple packages there, right? So practically speaking, at a component level of an architecture, you will have, of course, multiple packages deployed on the same component. Can we have a package within a package? Yes, you can have it, but it depends on the logic of, how you're really doing it.
Okay.
So far, so good, right?
Yes.
Good, alhamdulillah. So everybody is comfortable with me and in the concept that, when we are trying to design packages, and by the way, this is the same concept. If you really think about more closely, this coupling and cohesion concept goes back to the same ideas of the original classes as well, if you recall. And we want abstraction, right? Remember what was abstraction? Abstraction was all about having only things which are related, absolutely necessary for such system, right? And we wanted to encapsulate them, enclose them, and so on and so forth. Same principle is continuing. So basically, we want our classes to be more cohesive in nature, and of course, we want less coupling between packages. Now, how to come up with these packages? So far, I just showed you a dummy example here. So, just put them in here and there. But it cannot be ad hoc. It cannot be ad hoc. You need to follow some principles. Of course, I'm gonna just use these three as the example principles. This list is by no means a complete list, right? There are so many other options out there, but just gives you an idea how systematically you can come up with packages which are cohesive in nature. So let's look at them one by one now. Remember, cohesiveness means make a package in such a way that the classes are grouped together in such a way they are related to each other. So they have this common principle, common closure principle. This is option number one or principle number one. Common reuse principle and reuse release principle. So what are they? Let's. The common closure principle says the classes that change together belong together. Right. So in other words, when you are coming up with packages, put the classes together in one packages which gonna be changing together. This is one rule of thumb in a sense. So basically it says, because the thing is, as we just noticed and we just discussed, that coming up with these packages and testing them and releasing these packages is not an easy task. It's not just straightforward. It cannot be ad hoc. It cannot be random. And of course, the more the packages that changes in a given the release, the greater the work is to rebuild, test, and deploy those releases. In other words, if I have a system which consists of 10, 20 packages, and every time I make a change, and of course, as we all know, especially from your 215 discussions, requirements changes, right? And requirements changes for so many reasons, and as a result, your source code may be changing, and of course, your source code may be changing for many other reasons as well. So the more for a given release, for every release, if you have to, for example, out of the 10 packages, if you have to go and change all the 10 every time, it's really a very costly process, because you have to rebuild them, you have to retest them, you have to redeploy them. So you are interested in having cohesive packages, and the way this principle suggests to us that put the classes together which gonna be changing together. And the benefit here is that Therefore, if you put the classes together which are changing together, it will minimize the number of packages that are changed in a given release cycle. How is that? How this will happen?
Doctor,
Yes, please go ahead.
I have a question regarding the packages.
Go ahead, please. Go ahead. Go ahead.
If we classify the classes, each cohesive classes with each other, and there are still classes that's not belong to any package there. So what we do? Do we have to make their package on its own, or what we should do? Or it's a class that associated with more than one class that in different packages?
Okay, let me answer this. This is a very important question.
Yes.
So let me start with your second part of the question, which was that can I have a class which belongs to multiple packages, right?
Yes.
So let me start with this one. Now this will not happen, right? A class has to belong to a package. It cannot be in both packages, because remember, at the end of the day, these packages are going to be deployed, right? They're going to be executable files. Okay.
Yes.
So you cannot have a case where a package is actually part of a class is part of multiple packages. So let's clarify this first of all. Second is, it's a valid observation here that if I have 10 classes, and out of those 10 classes, if I apply this common closure principle, and then as a result I get basically, with this, if I get what you call classes which are changing together, I put them together, and I might be left with few of the classes which are not anywhere, right? No, this can happen, and probably it will happen, but this is where I was about to say this at the end, by the way, but I'll say it again here because we're talking about it, is that these principles are rule of thumbs here. Of course, as a designer, you have to still use your own judgment there, right? And you will also have to still use your own judgment to make these packages which are meaningful as well. Okay.
Yes.
Right. So I was gonna make this comment towards the end, but this is true that these principles which I'm gonna talk about, these 5-6 principles, they are good principles. They give you a guidelines, but at the end of the day, you still might have to use your own judgment to say that whether these packages making sense or not, right? At the end of the day, we want all classes to be in at least one package. Or I should be saying they will be in a one package. They cannot be in multiple packages anyway.
So in what way we would package them? Are the user interfaces in one package on because they are related in terms of user interface, right?
Yes. Okay.
And managerial classes, or how is it possible to?
Yes. No, this is the whole idea. This is the whole discussion we are having now. That how I'm gonna do this, right? So how exactly I'm gonna do this whole thing? How exactly I'm gonna do this? You have to do it in such a way that you satisfy the cohesive principle and you do satisfy the coupling principle, right? And at the moment we're focusing on the cohesive principle. One option for you is you apply this principle, which is the common closure principle, that you will put the classes together that changes together. You don't look at them from a user interface perspective or the business logic perspective. No, you say, if I make a change in this class and so there are 10 classes, and out of these 10 classes, these 5s will be changing, and hence I'll put them in one package, because then I will only have to change that package, right? So this is one way of looking at it, one way of doing it. Of course, it's not that straightforward, because anticipating change is also not that straightforward either, right? So, but it comes, so it comes with experience. It comes with understanding of the domain. So again, going back to your question, if I have 10 classes, how I'm going to group them together? This is exactly what we're discussing here. What we know for sure is that we want our classes, our packages to be cohesive, and we want our more cohesive, less coupling. This is for sure we know. For cohesiveness, one option is to go with this approach, this principle. Put the classes together that are going to be changing together. Okay.
It's clear. Yes.
Yes. So other option is we have another option, which is this is another principle for achieving cohesiveness. We have something called common reuse principle. This principle says that classes that are not reused together, here the focus is on the reuse, right? So if the classes are not reused together, don't put them together in one package. In other words, the classes which will be reused together, put them in one package. So this is a completely different philosophy for achieving cohesiveness. Here the focus is when the package changes, all the clients that package must verify that they work with a new package. So if nothing they or even if nothing they used within the package actually changed. What I really mean by this is that in a practical way, your packages will not be in isolation, right? These packages will be changed, will be interacting, as I said, they will have some coupling between them. And for example, if you come up with a package in such a way that the classes within it are not reused together, right? This means that if you're going to make a change in this package, so let's say you just ad hocly put them here. So if you're going to make changes, then all the clients that must use this package, so all these guys which are using this package, still have to make sure that the new package is still working for them, though nothing has changed within it. Correct?
Yes. Yes.
All right. So basically, this principle is all about saying the second option. This is second option, which is saying to you, please put the classes together in such a way that the classes which are going to be reused together, put them in one package. So in other words, yes, please go ahead.
Yes, Doctor, sometimes like you have classes that are reused together, but you have like some other classes that if you change this class, they will be affected by the change in this class.
Yes.
So you get some overlapping.
Exactly. And this is exactly I'm going to talk about in a minute. So just bear with me. You're absolutely spot on here. So just bear with me. So in other words, if the classes that are not used together are grouped together, what will happen? Then the changes to the classes that we don't really care, we'll still need to check them, and we still need to make sure that they are fine, right? Isn't it?
True.
So basically, the point you raised is that sometimes we like to put, if you have a package in a class which are being reused, but at the same time it's not really changing together, or there is another class which is with which it is changing, and so on and so forth. So it's actually a trade-off. You're spot on. They are actually, if you focus more closely, these two principles, this common closure principle, which is all focusing on the changes, and the common reuse principle, which is all focusing on the reuse, they're actually mutually exclusive. They cannot be simultaneously satisfied. See? They cannot be simultaneously satisfied. So in other words, you cannot come up with a package in which you say, I have put all the classes together, which are going to be changed together, and then all of these classes are going to be reused together as well, because that's not going to happen in a real application. All right. So they are mutually exclusive, and this means basically what? The reason they are mutually exclusive is because this common reuse principle, the focus is on reuse, right? While the common closure principle, the focus is for helping the maintainers. How this principle tries to help maintainers, and why this principle tries to help the reuse idea of the package. How is this happening? Anybody would like to make a comment on this?
Doctor.
Yes, please.
When you see say a reuse CRP as a reuse component, this means that I can take this package and use it in another application.
Okay. Yeah. Yes. So yeah. Yeah. Exactly. So we take this package and reuse it somewhere else.
Thank you.
Yes, absolutely. So how this, for example, because this is straightforward, by the way, but how this is helping maintainers? How CCP, common closure principle, is helping the maintainers?
Because you're coupling common or
Cohesive.
cohesive classes together, so it's easier to maintain and to know what's to maintain, what's not to maintain.
Yes, but remember, both principles gives you cohesive classes, right? But how the common closure principle is helping from a maintenance perspective? Both principles are giving cohesive classes. Yes.
Because if it's in the same package, you'd manage to know where it would change. Instead, if it's in the other package,
Exactly, spot on. Everybody on board with us here on this principle, this concept and difference between them? Both are cohesive principles, right? That's why we're talking about them. But they kind of serve different objectives. And we already know that they are mutually exclusive. It's very rare you will come. I mean, you can always come up with a counter example here, but very, very rarely this will happen, that you will be coming up with a package which is reusable, and at the same time, all the classes changing together, also grouped together, right? So, of course, the reason is, as a result, what happens is that this common, because it's trying to package cohesively packaged classes which are being changed together, so it will always tend to come up with packages which are larger in size, because you will always try to say, oh, let's put all the classes together which are going to be changing together. So you tend to have a larger package in this case, while the CRP, which is all about the reuse, they will tend to come up with the packages which are smaller in nature, because it's easy for you to reuse. Reusing the whole system or a large part of the system is usually very unlikely, because this doesn't really happen. So far, so good?
Yes.
Alhamdulillah. Any questions on this before I move on to the last part of this cohesive principle? Remember, we're only focusing on package cohesiveness at the moment. All right. Now, there is another option here, which is called, okay, before this actually, let's read this one, guys. Let's take a quick read of this one and let's discuss this. So what do you think, guys? What's happening here?
He suggests that in the early stages of architecture, it's better or it's preferable to use the CCP approach in designing the package diagram. After the architecture being stable, we would go to the CRP, so we could satisfy the external reusers.
Exactly. Perfectly summarized. Perfectly summarized. Everybody is comfortable with this, because these two are mutually exclusive. So practically speaking, when you're developing the application in the beginning, you always gonna try to package your classes from a cohesiveness perspective using the CCP principle. Because you're going to try, because see, the system is unstable at the moment, it's still changing, a lot of changes are happening, and you are trying to make sure that you put the classes together which are changing together for minimizing the effects and so on and so forth. But as the system becomes more stable, you can start thinking about how I can reuse part of it for another system within my company, or selling it or whatever, right? And then you can always refactor you can always refactor your packages from a reuse perspective. Not every time you have to do it, but if you're interested in reuse, you can always follow this approach. And this brings us to another principle, which is the last principle we're going to cover from a cohesiveness perspective, which is basically the reuse release equivalence principle. And what it says is that the unit, the granularity, the unit of the reuse is the granularity of the release. In other words, in the previous principle, there was no focus on a release. It was just reuse together, right? Here they say reuse equivalence is a case where you will basically do what? You will reuse the classes in a package, or you will group the the classes who are being reused together in a release, in a single release together. So it's more like, you know, one package released together, and it's more effective because it will become more like a complete black box package. So you can, like, for example, you know, the plugins you use, or the commercial of the shelf components you use, or like Google Maps you use in your mobile applications. It's like a black box to you. So this principle says put the classes in a package together in such a way that, you know, these classes are gonna be self-contained and released together. So that this package could be taken from this system A and plugged into a system B, and it will work. Right? Everybody's comfortable with me on these fundamental concepts?
Yes.
Alhamdulillah. I think it's almost 10:50 as well, so I'll stop the recording. Yes, please go ahead.
Can you again this principle? I didn't get it.
The last one.
Yeah.
Okay, let me repeat this one. So here we are saying that when I'm gonna come up with the cohesiveness of a package, and in other words, I'm gonna put the classes in it. I will do this way. I will look at the classes which will be reused and released together. So basically, you know, they work together and they give a functionality which could be released as one functionality, you know, together. So basically, I'll put all of these classes in one package so that I can actually go on and release this package. And when I'm going to release this package, by the way, the packages you guys use in your Java code, or if you do Python programming or any of those plugins, right? So basically, you use them as a one unit. So it becomes more like a black box to you. You don't really care what's happening inside it. You basically go on and use it, and you don't have to make any changes to that, right? So if this is the target, then you can use the reuse release equivalence principle to package your classes in a cohesive way. Now, of course, this is different from the first one, right? Or the second one, because this is focused on your unit is what? Unit of reuse is unit of release. Javad, is this clear now?
Yes, yes.
Okay, perfect. So let me stop the recording and let me take the attendance. And of course, the floor is open for any questions. Otherwise, inshallah, I'll see you on Tuesday.